What if I told you every one of these galaxies was once just a cloud of silent gas?
Because before galaxies existed, the universe was empty, absolutely empty. Then the Big Bang erupted, unleashing energy that created the first particles. As space expanded and cooled, hydrogen and helium began forming giant cosmic clouds.
Gravity pulled these clouds together, preparing the first steps toward galaxies.
When the clouds collapsed, the universe lit up with the very first stars.
Over millions of years, rotating stars shaped the elegant spiral arms we see today.
Soon, the cosmos filled with galaxies, spiral, elliptical, and beautifully irregular.
Galaxies collided and merged, growing larger and more complex.
Our own Milky Way is just one shining island in this cosmic ocean.
And it all began with nothing but gas, gravity, and time, the perfect recipe for galaxies. Hydrogen became the universe's fuel, the basic ingredient of every star.
Tiny density differences grew, guiding matter into clumps that gravity pulled tighter.
Shock waves moved through clouds, pushing them to collapse even faster.
Even the smallest disturbance could trigger the birth of an entire star system.
Stars rarely formed alone. They were born in clusters, like cosmic families. The center pulled in the most material, growing heavy and intensely bright.
The center pulled in the most material, growing heavy and intensely bright.
These orbits became the early blueprint of galactic structure.
Everything in a galaxy moves in harmony. Gravity is the conductor. Most of the mass didn't even shine. Dark matter held everything together.
This invisible halo prevented the galaxy from flying apart as it spun.
Dark matter formed gigantic cosmic highways where galaxies gathered. Our universe's structure is shaped by this silent, invisible framework.
Think of dark matter as the scaffolding that holds galaxies in place.
Galaxies spin so fast they should tear apart, but dark matter keeps them whole.
Scientists discovered dark matter by studying how stars orbit their galactic center. Even far from the center, stars move too fast to be held by visible matter alone.
Most of a galaxy's weight is invisible, silently shaping every motion.
Without dark matter, gas would never compress enough to make galaxies.
Entire galaxy clusters form at intersections of these dark matter webs.
Every bright spot you see is a galaxy held by gravity and dark matter. Some galaxies formed perfect disks as spinning gas settled into balance. Pressure waves rippled through the disk, sculpting the elegant spiral arms.
Spiral arms are not solid. They are waves guiding newborn stars.
Others became elliptical, shaped by violent collisions and mergers. Elliptical galaxies swirl with random motions instead of neat orbits. Some galaxies got shredded, turning irregular and unpredictable.
Galactic collisions were common, and they permanently changed galaxy shapes.
Mergers created dramatic tides that pulled stars into long, glowing streams.
These collisions often triggered starbursts, creating thousands of stars at once.
Groups of galaxies interacted constantly, reshaping themselves over billions of years. Our galaxy, the Milky Way, formed from countless ancient mergers.
Many small galaxies fell into it, leaving behind streams of stars.
These star streams still loop around our galaxy, evidence of its violent past. The center became packed with stars, creating a brilliant, glowing bulge.
At the heart lies a supermassive black hole, silently shaping our galaxy. Dark dust hides many stars, forming intricate patterns across our arms. Behind these dusty curtains are billions of stars we can barely see.
Our own sun was born in a cluster deep inside a spiral arm.
Over time, our solar system drifted away, leaving its siblings behind.
Today, the Milky Way holds hundreds of billions of stars, and we are just one.
Galaxies continue moving apart as the universe expands.
But some galaxies are on a collision course, like Andromeda and the Milky Way.
In 4 billion years, these giants will merge into a new mega-galaxy.
Even in collisions, stars rarely hit. Space is mostly empty.
After the chaos, a smooth elliptical galaxy will rise from the wreckage.
As galaxies age, they produce fewer new stars.
Eventually, galaxies will fade as fuel runs out and stars grow old. The cosmos will become quieter, colder, and more peaceful.
But for now, galaxies shine brightly, telling the story of time itself.
And that is how galaxies were born, built by gravity, shaped by time, and filled. As gravity tightens its grip, scattered cosmic dust begins to gather. Like dancers, rotation spreads the cloud outward, giving our newborn galaxy its first recognizable shape.
Every grain of dust follows curved paths, creating the spiral arms we see today.
Clusters of brilliant blue stars ignite, marking the galaxy's brightest, youngest neighborhoods.
Hydrogen clouds collapse, sparking fusion tools. The ultimate engine. Almost 90% of our galaxy's mass is not stars pref, but invisible matter we still cannot see. This ghostly halo is dark matter, shaping our galaxy like time. At the core, stars orbit at breathtaking speeds, pulled by unimaginable gravitational force. Here lies Sagittarius A6, the monster black hole that anchors our galaxy. Billions of older stars gather into a swollen central bulge, glowing with ancient light. The spiral arms are not solid structures, but waves where stars bunch up and drift apart.
Our galaxy has a bar, Kerm, a cosmic traffic system guiding gas toward the core.
We live in the Orion Arm, a small side street between two giant spirals.
These dark rivers of dust block light, sculpting the galaxy's dramatic pattern.
Stars move through the arms like cars on a highway, never staying in one place.
Our galaxy is a timeline. Older stars fill the center, younger ones populate the arms. Supernovae act like cosmic gardeners, clearing clouds and triggering new star birth. When neutron stars crash, they forge gold, platinum, and the rarest elements. Galaxies grow like living organisms, constantly feeding, changing, and adapting.
Over time, galaxies fall into each other's gravity, beginning a slow, elegant dance.
Their gravity pulls out glowing tails, creating spectacular bridges of stars.
Despite the chaos, stars rarely collide, Suri. Space between them is vast.
Eventually, they fuse, forming a larger, stronger structure.
Most galaxies fall into three main families: spiral, elliptical, and irregular.
Elliptical galaxies are giant spheres of old, quiet stars with little gas left. Irregular galaxies defy symmetry, shaped by violent interactions.
Our galaxy is a barred spiral masterpiece, stretching over 100,000 light years.
Stars far from the center move too fast, Alamul, a mystery explained by dark matter. As galaxies pull in gas and dust, new stars are born, slowly changing the galaxy's shape. Spiral galaxies form their arms because stars move at different speeds around the center.
Scientists classify galaxies into different types to understand how they evolve over time.
When galaxies collide, stars rarely crash, but gravity reshapes everything.
Galaxy mergers often trigger massive star formation, creating brighter and younger galaxies.
At the center of most galaxies lies a supermassive black hole controlling motion with gravity.
Galaxies are connected by dark matter, forming a giant cosmic web. Over time, spiral galaxies can transform into elliptical galaxies after repeated collisions. From tiny gas clouds to massive galaxies, the universe is still evolving, even today.
Understanding galaxies helps us understand where we came from and where the universe is going.